Hello everyone, welcome to my YouTube channel. So today I am going to discuss an important concept regarding increasing and decreasing property of a function. So in the whole video I will assuming the function to be increasing and do the same, and you just reverse the inequality and you will get all the same results for decreasing function. Okay, so let's start. So so first of all there is no relation between continuity and differentiability of a function and increasing or decreasing. Okay, increasing or decreasing property of a function. First of all, what do I mean by this? I want to mean that continuity or differentiability is not a required condition to check of whether a function is increasing or decreasing. A function is increasing or decreasing, it is just a functional property, nothing else. Okay, but if we have some extra condition given on that function, then it is easier to check whether the function is increasing or decreasing. Okay, and that's why it is important to know each and every concept and how do I use that. That is important. Okay, so I would like to mention the concept and behind this. Okay, so first thing is very important. The important thing is the definition. Okay, so let D be a subset of R. Say D is an interval. Okay, now definition. A function f is increasing on D. What is the meaning of this statement? For any x1 x2 belongs to D such that x1 greater than x2, f of x1 is greater or equal to f of x2, and f of x1 is greater than f of x2 in case of strictly increasing. Okay, so strictly increasing implies increasing. Increasing means it can be equal, but strictly increasing means it is just strict, the inequality is strict. Okay, so whenever x1 greater than x2, f of x1 greater than f of x2. So this is the definition. A function f is increasing on some interval D, mind it. Now second thing, the most of the students have doubt because of this problem of the language. Okay, so before going to solve any problem, you need to understand what is the meaning of the statement and what is the definition of the statement. Okay, so definition of increasing on an interval is given by this, and a function f is increasing at some point a. What is its meaning? Its meaning, number one, if a is an interior point, then there exists a delta greater than 0 such that f of x greater than f of a for all x belongs to a comma a plus delta, and f of x less than f of a for all x belongs to a minus delta comma a. So a function f is increasing at some point A, it's meaning that if A is an interior point, then there exists a delta greater than 0 such that fx greater than fa for all x belongs to a comma a plus delta, and fx less than fa for all x belongs to a minus delta comma a. Okay, and if A is the boundary point, then say if the interval D is looks like say P comma Q, then for P the definition looks like there exists a delta greater than 0 such that fx greater than fp for all x belongs to P comma P plus delta. And for Q, so for P we don't need to check the negative part because the domain itself is closed interval P comma Q. Okay, so in domain for P only right hand side exists, right hand side part is in the interval, left part is not in the interval, so we don't need to check. And even if the function is not defined, function is defined on D, right? So this is the thing. And if A is boundary point, here the boundary point is P and Q. So for P the definition looks like there exists a delta greater than 0 such that fx greater than fp for all x belongs to P comma P plus delta, and for Q fx less than fq for all x belongs to Q minus delta comma Q. This is the definition. So the two definitions are completely different. A function f is increasing on some interval D. That means if you choose any 2 point x1 and x2 and that satisfies x1 greater than x2, then f of x1 greater or equal to f of x2. This is the definition. And second one, a function f is increasing at some point A. This has different meaning. And the meaning is this one. If A is the interior point, then you can find a delta such that fx greater than fa for all x belongs to a comma a plus delta, and fx less than fa for all x belongs to a minus delta comma a. Most of the students have the same confusion because of they are thinking increasing means same for everywhere. It is not like that. The two different concepts. This is by the definition. Okay, this is the definition of a function f is increasing at some point, and this is the definition that a function f is increasing on some interval. So if you clearly understand these two definition and these two difference of these two definition, then you will able to solve all the problems. Okay, now come to the next fact. So this is the definition, right? Okay, now some important facts. So let D is subset of R and f is defined on D. F is real differentiable and f prime greater than 0. F prime greater than 0. That means f prime x greater than 0 for all x belongs to D. Then f is increasing on D. Okay, so D is subset of R if f prime greater than 0 for all x belongs to D, that will imply f is increasing on D. And you know, I have already mentioned the definition of a function being increasing on an interval. This is the meaning of that. Okay, and second property, if f prime a is greater than 0 for some a, this will imply f is increasing at point A. And I have already mentioned what is the meaning of a function being increasing at some point. Okay, so this is important. And then the very important fact that the converse. Suppose f is increasing on D. Okay, first of all, f is increasing on D, and f is given that f is differentiable. You need this extra condition, and plus it is given that f is differentiable. Then f prime x is greater or equal to 0 for all x belongs to D. Not strictly. Even if f is strictly increasing on D, it can happen that f prime x is 0 at some point. Example, fx equal to x cube. It is strictly increasing, but f prime 0 is 0. So that's why the condition is greater or equal to for the converse case. And similarly you can do for decreasing case also. Okay. Now, so the most important thing I will suggest you again, please read these two definition again. A function is increasing on T, what is its meaning? And a function is increasing at some point A, what is its meaning? Okay, when the point is interior point and when the point is boundary point. This is the definition. Fine. Okay, let's move to the actual question. So this is the PYQ of 2021. Okay, and many students have doubt in this problem. This is JAM 2021. JAM 2021 PYQ. So if you understand the definition, what I have written properly, then you can solve this problem. Okay. So go. Let f a comma b to r be a differentiable function on AB. Okay. First option, if f prime greater than 0 in open interval a comma b, implies f is increasing in a comma b. This is true by the definition. I have already mentioned the fact, right? This is the fact. This is the fact I have already mentioned. This is the statement, right? So that means first statement is correct. Okay. Now the second one, f is increasing in a comma b implies f dash greater than 0. This is clearly false. Why? You can take particular fx equal to x cube on say minus 1 comma 1. It is strictly increasing function, but f prime 0 is 0. Hence second one is false. Third one, if f prime x naught greater than 0 for some x naught, then there exists a delta greater than 0 such that fx greater than fx naught for all x belongs to x naught comma x naught plus delta. This statement is also true because f prime x naught greater than 0, this will imply f is increasing at x naught, and f is increasing at x naught. What is its meaning? Here the interval is open interval a comma b, right? So that means x naught must be the interior point. So there exists a delta greater than 0 such that fx greater than f of x naught for all x belongs to x naught comma x naught plus delta, and fx less than fx naught for all x belongs to x naught minus delta comma x naught. Okay, so that means third one is also correct because it is saying that if f prime x naught is greater than 0, that will imply f is increasing at x naught, and that will imply by definition this condition, right? That will imply by definition this condition. And fourth one is, if f prime x naught greater than 0 for some x naught, then f is increasing in a neighborhood of x naught. Okay, now understand the meaning. F is increasing in a neighborhood of x naught. What is its meaning? So f is increasing in a neighborhood of x naught. What is its meaning? First of all, a neighborhood of x naught means what? Neighborhood of x naught means there exists a delta greater than 0 such that I looks like x naught minus delta comma x naught plus delta. Now the question becomes f is increasing in x naught minus delta in I, which is equal to x naught minus delta comma x naught plus delta. So whenever I am telling that f is increasing in I or on I, where the I is x naught minus delta comma x naught plus delta, that means it is an interval. So whenever I am telling that f is increasing on an interval, then I need to see the definition of being increasing on some interval, which is this one. This one. This one is my definition now. Right? Okay. But this definition is not correct. So this is the definition, right? But this statement is not correct because I have given just f prime x naught is greater than 0 for some x naught, then f is increasing in neighborhood of x naught. That is false. And the counter example is actually the second question. Okay. So how do you construct the counter example? The counter example is actually the next problem that I am going to solve now. So that means in this problem, you can see that whenever I am talking about f is increasing in a neighborhood of x naught, that is an interval. So whenever I am telling that f is increasing in a neighborhood of x naught, that means I am asking that f is increasing in some neighborhood of x naught, means in some interval. Then I need to use the definition of a function being increasing on the interval. Okay. But the third option is saying that f is increasing at some point a. Here the point is x naught, and that has different meaning, and that's why I first mentioned the two different concept, two different meaning, that a function being differentiable on an interval and the function being function being increasing on an interval and the function being increasing at some particular point, both have different meaning. So I have already mentioned that. That's why A and C are correct here. If you check the answer key, you will see that A and C are correct. But many students have did mistake and make D also correct, but D is not correct. And the counter example is given by the next problem. This is the problem. So the problem says that the function fx is given by fx equal to x plus x square times cos pi by x when x not equal to 0 and 0 when x equal to 0. First of all, when x not equal to 0, f is clearly differentiable. You can see that, right? The only thing is that I need to check whether f is differentiable at 0 or not. So check. So I need to check this limit. If f dash 0 exists, that will imply limit x goes to 0 fx minus f0 by x minus 0. This limit must exist, which is same as limit x goes to 0 x plus x square cos pi by x, f0 is 0 by given by x, which is same as limit x goes to 0 1 plus x cos pi by x. Now cos is bounded function, right? That means as x goes to 0, x times cos pi by x also goes to 0. Hence the limit is 1 and limit exists, right? That means f is differentiable on R. There is no problem. So in particular, f is differentiable at 0. So first statement, f dash 0 exists and it is equal to 1. That is correct. F dash 0 exists and equal to 1 by definition. Okay. Now the second thing is that f is not increasing in any neighborhood of 0. Third one is f dash 0 doesn't exist. So that is clearly false. And fourth one is f is increasing on R. Okay. So in both cases, say f is increasing on R. Say f is increasing on R. That means for any x1 greater than x2, f of x1 must be greater than f of x2, right? And suppose f is increasing in some neighborhood of 0. Suppose f is increasing in some neighborhood of 0, then say there exists a delta greater than 0 such that f is increasing. Suppose there is a delta greater than 0 such that f is increasing on So minus delta comma delta. Okay, increasing in neighborhood of 0, that means minus delta comma delta. Okay, then that means I am choosing here minus delta comma delta as my interval, and then we need to check whether f is increasing on this or not. Okay, okay, but the thing is that f is not increasing in any neighborhood of 0. See, f dash 0 exists. Now this is very important part. Okay, very important, very important. We have f dash 0 equal to 1, which is greater than 0. This will imply f is increasing at 0. Now what does it imply? There exists a delta greater than 0 such that fx greater than f0, which is 0, for all x belongs to 0 comma delta, and fx less than f0, which is 0, for all x belongs to minus delta comma 0. So f is increasing at 0. Since f dash 0 equal to 1, which is greater than 0, that will imply f is increasing at 0, and that will imply these two condition holds. But when I need to check that whether f is increasing on some interval, I need to check that x1 greater than x2 implies f of x1 greater than f of x2, right? I need to check this, right? I need to check this. But this property may not hold here, because here from the condition it is saying that fx greater than 0 on this interval, and here it is saying that fx less than 0 on this interval. But it doesn't imply that whenever you are taking x1 and x2 to different point, f of x1 greater than f of x2, whether it is true or not. We can't get information from this, right? So to check this, what we need to show here? So let take the derivative. What is the derivative? It is x plus x square cos pi by x, right? So that means 1 plus 2x cos pi by x, 2x cos pi by x minus x square sin pi by x times pi by x square, which is 1 plus 2x cos pi by x minus sin pi by x. Okay. Now the very important thing is here that I already mentioned, I have already written in above that if f is differentiable, see f is differentiable on real line, right? So that means f is differentiable on any interval containing 0. So f is differentiable plus increasing, then f prime x is greater or equal to 0 for all x belongs to increasing on I, right? Now in particular, say choose I to be minus delta comma delta. For any delta greater than 0, choose I to be minus delta comma delta. And if f is increasing on I, then f prime x is greater or equal to 0 for all x belongs to minus delta comma delta, right? But if you check, this is your derivative and I is minus delta comma delta. Cos and sine both are oscillatory function. Now it is your homework that whenever you choose any delta, in that neighborhood minus delta comma delta, you can always find 2 points where for one point f dash x is less than 0 and another one point f dash x is greater than 0. That means it is not consistent that f prime x is greater or equal to 0 for all x. Okay, That's why f is not increasing in this neighborhood minus delta comma delta. And that delta, you can choose any delta greater than 0. For every delta this will happen because of the oscillatory property of cos and sine, cos pi by x and sine pi by x. It is your homework to find actual. Okay, so that means you can't find any delta such that f dash x greater equal to 0 for all x belongs to minus delta comma delta. That means f is not increasing on any neighborhood of 0. Because if f is increasing on some neighborhood of 0, that means you can find the delta such that f is increasing on the interval minus delta comma delta, and since f is differentiable plus f is increasing on minus delta comma delta, that will imply f prime x is greater equal to 0 for all x belongs to minus delta comma delta, which is not true because of the oscillatory property of this function. That means here f is not increasing in any neighborhood of 0. Okay, that's why 1 and 2, these two options are correct and other two options are false. But f is increasing at 0. Okay, f is not increasing in any neighborhood of 0 because of, by the definition of a function being increasing on an interval, but f is increasing at 0, and f is increasing at 0, that's why fx greater than f0, that means fx is positive when x greater than 0 at some delta, and fx less than f0 for fx less than 0 for all x belongs to minus delta comma delta. That means f is increasing at 0, but f is not increasing in any neighborhood. Okay, so I hope all of your doubts will be clear after seeing this video. But the most important thing in this video is that you need to know the definition of two important things. One is a function being function being increasing or decreasing on an interval, and a function being increasing at some point. Both have two different meaning. Okay, both have two different meaning. Very, very important. So both have two different meaning. Both have two different meaning. You need to know this. Okay, then you can solve it. Okay. Okay. So now I hope this is clear, and these are the facts that if f is differentiable, then f prime greater than 0 implies f is increasing on that interval, and at some point if f prime greater than 0 means f is increasing at that point. This is the theory. Okay. Okay, I hope this is clear. If you have any doubt, just comment below. Thank you.